Okay, so in the previous video, you saw exactly how to do some of those finding those features questions on your calculator. I know that there's only one example going on there, but if you need to see it again, rewatch it and rewatch it. I will also, continue to be supporting those things as we go. And if you need questions answered, please come to those help meets and everything. Okay, so now we have two kinds of equations for parabolas. We have vertex form and we have standard form. Now, standard form doesn't tell you a lot of information right off the bat. Vertex form will actually tell you the vertex right away. The one piece of information that the standard form will tell you right away is your vertical scale factor, and it's still A. It's the same A. So I can write these are the same. And that's an important thing. So you need to know that this standard form has a scale factor written in it, just like the A is here. Okay. It also tells you what your y-intercept is. The y-intercept is going to be given right here. The y-intercept is written as 0c. B doesn't tell you a lot. So let's jump into kind of how we would find those features from standard form without a calculator. I know the book is kind of tending to use y equals, and I use y equals a lot of the time, but just remember that f of x basically means the same thing as y equals. It just allows us to tell you what you're putting in. And so if you need to find the vertex given an equation in standard form, the x value of the vertex is negative b over 2a. The y value of the vertex is what you get when you put that x value back in to x's there. That's what this f of negative b over 2a, that's what that expression means right there. So let's do a little practice. So let's find the vertex of this function. Oh, look, there's no a written. That's because it's an invisible 1. So the vertex is the point negative b over 2a, f of negative b over 2a. So let's figure out what negative b over 2a is. Negative b over 2a is negative 2 over 2 times a is 1. Okay, so negative 2 divided, 2 times 1 is 2. So negative 2 divided by 2 is 1. Negative 1. So my vertex has the x value of negative 1. My vertex has the y value f of negative 1. What that says is take that negative 1 and put it in for x right here and here. I'm going to rewrite that whole thing up here so that I can keep track of what's going on. 1 times negative 1 squared plus 2 times negative 1 plus 3. Okay, careful of your order of operations stuff here, but negative 1 squared is positive 1. I'm going to cry if you say that negative 1 squared is negative 1. It's not, it's positive 1. So then this whole thing is 1 plus negative 2 is negative 1 plus 3 is 2. So my vertex is the point negative 1, 2. The point negative 1, 2 is right here. My vertical scale factor is 1. And so I'm going to follow my normal, go over 1, go up 1, go over 2 from the vertex, go up 4, go over 3, and go up 9. So I'd be right about there. Yeah. Okay, so my parabola will look like this. Okay, so the vertex is at this point. I used this calculation to get it. Then I use the scale factor to figure out what my graph looks like. Now remember that I'm going off of the original equation y equals x squared, which looks like this. And if you don't remember what's going on there, you need to go back in the video and in the videos and watch why I said that this is what the original graph looks like. This is the parent function y equals x squared. Notice that this black graph, y equals x squared plus 2x plus 3, has the same shape because the scale factor is the same, but it has been translated up and over. I'm going to start by doing the same thing on this graph. I'm going to find the vertex. I'm going to graph it. I'm going to use the scale factor to, compare to the original parent function and stretch everything out and figure out what that looks like. But then I also want to rewrite this function in vertex form because I want to start getting into the habit of having the ability to change between different forms. So here we go. The vertex is at the point negative b over 2a f of negative b over 2a. Okay, so what's negative b over 2a? Well, negative 10 over 2 times 2 is negative 10 over 4, which is 2.5, negative 2.5. So that's the x value of the vertex. What is the y value of the vertex? It's what happens when you take your x value of your vertex and put it back into the function right here. So let me just write vertex. Vertex is the point negative 2.5 something. So I'm going to take my negative 2.5, put it in there. I'm going to rewrite. Okay. I'm going to use my calculator because I'm lazy. Pull your TI-84 out and you can just literally type this whole thing in and hit enter. And I got negative 5.5. Now I know that this is not like awesome for us to be using these decimals, but hey, I want to make sure that you're being able to be flexible about using these decimals. So negative 2.5, negative 5.5 is the point right here. Nope, just kidding, it's not. It's this point right here. Okay, now our scale factor is 2. So I'm going to stop right here and I'm going to rewrite in vertex form. So I'm going to write in y equals a x minus h squared plus k. Okay, so I have my vertex, I have h and k, this is h and this is k. My scale factor is a is 2 because it's the same as this 2 right here. So I can rewrite y equals 2 x, and I'm just going to write plus 2.5 squared minus 5.5. This is in vertex form now. This is the same function as this one. They're equal, they do the same thing. Okay. Now let's do the graphing part. I'm going to start with my original function, x squared, which looks like this. This is y equals x squared. My scale factor here is 1, but now my scale factor on this new function is 2. So normally I would start at the vertex and go over and up 1, but this time I'm going to go over from the vertex 1 and up 2 because the scale factor is 2. Normally from the vertex I would go over 1, 2 and go up 4, but since my scale factor is 2, I'm going to go over 2 up, not 4, but 8. 1, 2, 3, 4, 5, 6, 7, 8 right there. Mirror it over there. The last one, normally I would go over 3 and up 9, but because my scale factor is 2, I go up 18. So go over 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right there-ish. And mirror it over here. So my new graph is what happens when I graph all of these points together. Again, this does not have to be perfect. Like that. Done. So I have the graph and I have the vertex form for the function. Notice I use the negative b over 2a calculation to find the vertex. I use the scale factor to rewrite it in vertex form down here. And then I graph the function. You do have sort of a long-ish textbook assignment for today. Try to be patient and try to get through all of it because I want to make sure that you have the skills to use vertex and standard form to find features of the graph and graph the functions right away, right at on the first day of this unit. Because if you don't, then this unit is going to get really, really challenging really fast. And I want to make sure that you have the background knowledge to be able to do really well on this unit. So work hard on the practice, and then there is a mastery check at the end of the day today. Thanks for your hard work. Have a good one.